Plastic products are everywhere in our daily life. However, some of these products are only used briefly, for example, packaging. And that brings us to the question, what to do with these products when they are no longer used. In Germany, plastic is also called Kunststoff, which can be translated as artificial stuff. That brings us to the point. Plastic is an artificial material with properties which can be matched to the purpose they are used for. We need stiff packaging for blueberries? No problem. Or flexible packaging for cheese? Also no problem. And why do products made from plastic have such different properties? Basically, because their underlying chemical structure and physical properties can be defined accordingly. Let's look at an example. This is the structure of polyester. It's also called PET, and it consists out of triethylenic acid and ethylene glycol. You will recognize products made from PET by their recycling code, which is identical in most parts of the world. It allows us to easily identify a polymer when we want to recycle it. Typical products made from PET are bottles, fruit packaging, and textiles. Obviously, these products must be made from materials which have very different properties. This becomes very evident when comparing the bottle with a textile. The bottle is much stiffer than the textile, and that's exactly what we want, because otherwise we would not really enjoy wearing the textile. Now let's take a look at the chemical structure of these products. PET is made of carbon, oxygen and hydrogen. Simply speaking, the length of the molecular chain and the structure determines the stiffness of the polymer. The stiffness is also referred to as viscosity. Low stiffness, low viscosity, high stiffness, high viscosity. The viscosity of polyester is typically measured as the intrinsic viscosity, abbreviated to IV. The IV of a bottle is approximately 0.8, IV of a tray 0.7, and the IV of a fiber about 0.64. Let's summarize. By determining the chemical structure of a polymer, we define its properties. And even for the same kind of polymer or plastic, different chemical structures exist. Now, what does that all mean for the recycling process and recycling possibilities for the plastic product? For polymer recycling, we normally need to melt the plastic. By melting the material, the molecule chains become mobile and some of them are broken up by heat energy and residual moisture. Now, to reconnect these molecule chains is not that easy, and the extent to which it is possible at all very much depends on the polymer itself. Also, normally, the harder you try to reconnect the chains, the more energy and reaction time you need to invest. Another problem, when we take a product which has been used, maybe for a long period of time, it is no longer pure. It is dirty, and some of the dirt we can easily see, but some contamination we cannot see. Contamination could be, for example, water if the material has been stored outside. It could be sand, steel, paper, sugar or other polymers. Consequently, if water is present during the melting process, it will split the molecule chains by hydrolysis. Fortunately, this reaction can be reversed. Unfortunately, some of the impurities can react with the end groups of the molecule chains to create so-called dead chain ends, with consequence that a chain reunification cannot take place. One conclusion is we need to get rid of the contamination before melting the polymer. The less contamination, the cleaner the material, the better. And now you might say, why don't we just wash it? And yes, that's exactly what's done in recycling processes. Normally the material is washed in specifically designed washing lines. It's anything else but an easy process. It's actually rather complex. Typical steps when washing used PET bottles are sorting, cutting, hot wash, swim sink separation, and drying. The first step after collection is the sorting of the bottles in order to sort out larger contaminants and products from foreign materials or cross-contamination by other plastics. After that, a complex washing process is used to wash off dirt and contaminants. Typically, further sorting will take place after the bottles are cut into pieces. For example, the swing sim process which uses differences in density, dry sorting using cameras and/or light detectors. As you can imagine, the washing process is very much depending on the amount and type of contamination, and that is typically very different from country to country, as it depends a lot on how the bottles are collected and sorted. As a consequence, a very important condition for an efficient recycling process is a more or less stable feedstock quality. If you cannot assure this, you will have it very hard to ensure a consistent output quality, as otherwise the washing process will need to be continuously adapted to input quality. Recycling becomes particularly critical when we see a lot of contamination with foreign polymers. These are often very difficult to separate in the waste stream. In the case of multi-layer films or other material mixes, a separation often is not possible at all. A typical example would be a t-shirt made of PET and cotton. In this case, mechanical recycling is almost impossible. Therefore, when designing a plastic product using only one polymer is very important and very helpful for the recycling process. By the way, this is also the reason why the recycling of polyester bottle flakes is so successful. Not only is PET well suited for recycling, it is also easy to identify if it is used as a bottle. Almost all drinking bottles are made of polyester, which makes the collection process relatively easy. You do not have to be an expert to separate a drinking bottle from the rest of the waste stream. To summarize, for an efficient and effective washing process, we need a constant feedstock and we want as little cross-contamination with foreign polymers as possible. If this is the case, we can expect at the end of the washing process a more or less clean material.
More or less clean. What does this mean? Well, as we have seen, how clean the bottle flakes are is very much determined by the quality of the washing process. However, the flakes will never be 100% clean. Typical leftovers are smaller medical particles, glue, oils or other volatile contaminants, and some residual cross-contamination with other polymers such as PP, PE or PVC. These small contaminants have a significant influence on the usability of the recycled polymer. Therefore, further cleaning procedures must be used. Obviously, you can imagine that there are big differences regarding the quality of the sorting and washing process used. However, in pretty much all cases, further cleaning procedures are necessary in order to remove volatile contaminants and small solid contaminants.
Let's start with the volatile contaminants. These could be oils, acids or other contaminants which could be, in a worst case scenario, toxic if present in too large amounts. Therefore, they have to be removed, particularly if the polymer is intended to be used in food packaging later on. Examples would be PET bottles or food trays which are thermoformed out of sheet. Some cleaning processes are so efficient that they can decontaminate the polymer and will lead to a food contact approved product. In the solid state, this means decontamination of the flakes without melting them. Removal of the volatiles is normally achieved by temperature, long residence time of the flakes under vacuum, nitrogen, hot air or treatment with a cleaning solution. Another possibility to remove the volatile contaminant is to melt the polymer and degas it while it is fluid or in the liquid phase. The process can be compared to cooking out dirt or odor from clothing. In the liquid stage, the hotter the polymer process temperature, the more efficient the decontamination process can be, and the temperature of a polymer is typically quite high. E.g., for PET, a typical processing temperature would be around 280 degrees Celsius. The high temperature during the decontamination process leads to a much shorter residence times for a different decontamination performance or a better decontamination result given a defined residence time.
In this context, it is important to know that all so-called mechanical recycling processes are based on extrusion processes. In these processes, the plastic is put into an extrusion system where it is molten. Since the waste has already been cut into small pieces, it can easily be fed into the extrusion system. This is in contrast to so-called chemical recycling processes where the polymer is typically dissolved in a solution and the chemical chains break up to a full extent. Typically, chemical recycling processes are by far more complex and operate with a higher energy consumption than mechanical recycling processes. However, they are also able to deal with higher levels of contamination than mechanical recycling processes. For a mechanical recycling process, there are several different types of extrusion systems available on the market. Some have only one big screw and some have two or even more screws. There are specialized extrusion systems for such decontamination tasks available on the market, and the animation shows a so-called multi-rotation system MRS, which spreads and exchanges the melt over several smaller screws in the venting section in order to reach a high degassing performance.
Let us summarize. To thoroughly clean the plastic from volatile contaminants such as oils or toxic chemicals, typically cleaning processes are used which are based on high vacuum levels and or nitrogen or hot air treatment of the polymer. The cleaning processes can take place in the solid as well in the molten stage of the polymer. Now, what we have seen so far is we have sorted the waste, we have washed the plastic, and we have cut it into small pieces, and we have decontaminated it. However, all this leaves us with some smaller solid contaminants which will need to be filtered out of the polymer. This is done in the melt stage, after melting the polymer, typically in an extrusion process.
Typically, the solid contaminants are filtered out of the polymer stream by woven metal mesh filters. For high contamination loads, also steel plates or drums with small holes, so-called laser filters, are sometimes encountered. In all these cases, the screens or filter plates will have to be cleaned automatically if post-consumer recycled material is used. Otherwise, the filter would quickly be blocked due to the high contamination load, and the replacement process could lead to continuous process interruptions. Here we can see an example of an automatic pressure constant continuous filtration system with an integrated and highly efficient backflushing system, the RSF Gneuss from Gneuss. The filtration principle is based on a disc equipped with filter elements which rotates through the polymer stream. A very small portion of the cleaned polymer is used to clean the filter elements by backflushing. As a consequence, the filter elements can be used for a very long period of time. Also, when replacing the filter elements at the end of their lifetime, the production process continues without interruption. Now, which cleaning steps have we seen so far? We have washed the polymer, we have decontaminated it, and we have filtered it. As a result, we now can expect a good, clean, recycled polymer. However, keep in mind that we might still have quality restrictions resulting from the mentioned limitations of putting the molecular chains back together.
What can we do with the recycled polymer? Well, we have various options. Looking at the example of polyester bottles, we could use it to produce polyester bottles again, film for food packaging, fibers and filaments, strapping tape. Depending on the quality of the recycled polymer, we could use up to 100% of recycled material. However, typically we see only limited percentages used, for example between 10 and 40%. Reasons are limitations in chain structure and color of the recycled polymer. However, there are also some legal restrictions. If we want to use the recycled material for food packaging applications, we will have to respect some legal restraints. There are several international and national institutions which judge or certify the cleaning efficiency of the process. The most well-known are the US-American FDA, Food and Drug Administration, and the European EFSA, European Food Safety Authority. Recycled material which is intended for use in food packaging will have to meet the quality criteria of these institutions. There are several different techniques available on the market for polymer recycling, and they are characterized by big difference with regards to energy consumption, maintenance and running expenses. Also, the final product quality is strongly linked to the underlying recycling process.
As a consequence, it's very important to choose the right technology for your specific application. Specialized companies such as Gneuss live recycling every day. If you have further questions or you need information for a specific project, please feel free to contact us. If you like this video or you have suggestions, please leave a comment or like. We are looking forward to hearing from you.